This is a Banarasi silk sari. Its value comes from its high-purity silk and intricate gold work, creating a physical record of the family history woven into the fabric. These luxury textiles have long been among our most prized possessions. In 1889, First Lady Carolyn Harrison wore this ornate lace garment to signify her status and influence. However, even when kept in dark, secluded closets, these materials are slowly failing. Protecting this legacy requires active intervention to stop chemical and mechanical degradation occurring at the molecular level. Owners often rely on common household habits, plastic wrapping, mothballs, or a gentle wash in water. But as you can see, simply saturating the threads in clear water causes the individual fibers to physically distort. These protective measures are often the direct cause of silk shattering, color loss, and the blackening of metallic threads. To save them, we have to look towards the science of textile conservation. The problem begins with the fabric's biological origin. Silk is a natural protein fiber spun by silkworms. The primary protein in these fibers is called fibroin. When we examine fibroin under a microscope, we find it is filled with thousands of tiny, empty openings known as micropores. During a standard wash, water molecules rush into these micropores. This causes the entire fibroin structure to swell and bulge outward. This swelling creates significant internal mechanical stress. As the fiber expands, it develops tiny microfractures throughout its internal structure. Common laundry soaps strip the silk's natural oils, leaving these fractured fibers brittle and unable to flex. Subjecting silk to a traditional water wash creates a cycle of structural expansion and chemical stripping that leaves the fibers prone to breakage. The risk is highest for weighted silks. Manufacturers historically treated gowns with tin salts to increase weight. These embedded metals are highly reactive. They are sensitive to ambient humidity, alcohol-based perfumes, and the chemical vapors released by mothballs. Exposure triggers rapid oxidation, blackening the thread and corroding its edges. In tin-weighted silks, this reaction can even release hydrochloric acid within the weave. Without specialized intervention, these chemical reactions will compromise the surrounding fabric, causing the entire garment to disintegrate. To prevent this, conservators turn to specialized dry cleaning, a process developed specifically to solve these chemical instabilities. Specialists first perform an expert inspection, identifying fiber vulnerabilities and targeting stains without introducing water. The core process relies on organic solvents. Unlike water, these liquids dissolve surface dirt and oils without entering the fibroin protein's micropores. Because the fibers do not swell, the garment maintains its shape and strength. The silk remains flexible and structurally intact. The process ends with a finishing phase, using low-heat steaming and manual reshaping to restore the fabric's natural fall without damaging delicate embroidery. Professional dry cleaning functions as a tool for chemical stabilization, resetting the clock on the garment's decay. While professional cleaning stabilizes the fabric, its long-term survival depends on how it is stored at home. Standard plastic bags trap moisture and should be avoided. Instead, garments should be wrapped in breathable muslin or unbleached cotton. For maximum safety, these bundles are placed into archival boxes made of acid-free and lignin-free barrier boards. These boxes are buffered with These environmental standards match the protocols used by the National Archives to protect our most significant cultural treasures. Every piece of hand-woven silk represents months of specialized labor and artistic tradition. Preserving that history requires a similar manual effort, using modern science to keep these woven stories physically intact. By applying precise chemical care, we ensure these heirlooms survive to be worn and admired by future generations.